All right, let's take a look at the fourth problem from the Google Codejam qualification round. Looks like this one starts to get hard based on the score bar. So let's see how it goes. We have n modules. We have a graph. Okay. We have initiators. And then they trigger stuff and they go to this like root node, I guess. I see. The fun is the max amount of fun. And then we trigger each of the initiators. I don't understand why it matters what order. I see. Okay. This thing only gets triggered once. Yes, that would be more fun. I agree. Interesting. Okay, I think I kind of see how to do this. So the idea is that, well, we have a tree, right? You can think of a tree rooted at the abyss. And then we want to know how much how much overall fun we can have across the entire tree. So we can sort of define this recursively. Like let f of x be the fun we can have at a tree in a subtree rooted at a certain node. And then the idea is, basically the fun of a node is the sum of the fun of its children, except that one of the children you can max with the node, the lowest one, I guess. And I think that's it, basically. So I think this is the key formula. Let's give it a try and see. And I guess the way to think about this is you're sort of working backwards, right? Rather than like, which leaf should I start with? You ask, let me go down from 60. Like, which subtree should 60 move into? Right, so we have n, and then we have fun, and then we have the parents. And I'm just going to treat the abyss as another node, because I think that will simplify my life. So now we just need to compute the answer and solve the problem. So compute for all the children, and then sort, and take our max with the smallest child, and then add in the rest of the children. And that's it. I think that's it. Team. Okay, we need the state as well. That should be how sort works in C++, but it absolutely is not. How do I keep forgetting to read in these things? Okay. That was not the right answer. Probably because I'm having 0 point back to itself. That's not correct. 110, 14, 490. That looks better. Okay, let's give it a try. I don't think we need, I think this is fast because we're just basically going through the entire tree once. There's no extra recursion going on here. It's wrong though. Really? Why is that? Oh, right. I'm maxing with the wrong thing. Because this is the total amount of fun, but the max is over a single path. So I guess we need to return the worst single path. This is getting more fraught. It should be P 100,000. Yeah, also it seems like what you do at one level might be affected by the next levels up. Is that true? We just want a list of paths instead of overall sum. Is that too much information? Seems like it is. What can the numbers be? 9. Help. There is a DP here where you take your current node and a value from your parent, but it's not full. Well, I mean, that will give me the first 2 test cases, but it's n squared. Which n possible values from your parent, I think. I think we can do this. maybe that. It is true that it is unused. 110, 14, 490. So the idea is we keep track of all the paths that go up to the root, and then we just connect up the worst one to ourselves. And it looks like that's correct. We don't know about test set 3, but it ran fast enough, and we got test set 1 and 2 correct, so it's probably right. Okay, yeah, that was definitely a little trickier. But I think this greedy approach is correct. Right, so I mean, the point is, like, you can think of this as picking like one edge from each node that's like a real edge. And then you take the sum across all, so this breaks the tree into like a bunch of paths, and then you take the sum across all the paths of the max. And so the question, confronting you at each node is, which child should I draw the real edge to? And the answer is, well, already, you can keep track of like what paths end at each of your children, right? There's only one path that ends at each child, because each child only has one real edge as well. And then you should draw the edge to the child that has the lowest value path, since you're the most likely to contribute to that. So that's what we do, right? So we need to keep track of the sum of all the paths in the subtree, and then also the actual value of the path that ends, at the root at x. So if we have a leaf, well, that's we just have the single path just containing that node. So that's the sum and also the value. And otherwise, for our children, we can add up all the values in their paths, and we're going to take the min across the children of the path that actually ends at that child. And then if that min is less than our value, then we can contribute by drawing an edge, to that path. In which case we increase our answer by this amount, and the score of the worst path now becomes f of x. Actually, this is not correct, because the worst path is either, it might not be f of x, worst path is not a good name for this. We want the path ending at x, which it definitely is f of x in this case. Okay, so it's correct, it's just confusingly named. Right, because one of our children might have a lower value, but that's inaccessible from our parent. Right, because our parent can only draw an edge to us, he can't draw an edge directly to our grandchildren. So, yeah. And then other than that, just reading in the values, treating the abyss as node 0 is super helpful. They clearly designed the input with that in mind. And then just run our function, and we don't care about the value of the path ending at the root, we just care about the total sum of all the paths. And that is it for this problem.